Hello and welcome to the third of our Revit Starter series, Revit Collaboration. So today we're going to take a look at some of the collaborative tools that we have available within Revit. For anybody that hasn't seen the first or second of our Revit series videos, allow me to introduce myself. I'm Mark Calloway and I'm one of the application engineers here at Man and Machine. Also, if you haven't yet seen the first or second video in the series, do go and check out the Man and Machine YouTube channel where you'll be able to find those. So as mentioned, we're going to have a look at some of the collaborative tools available to us within Revit. So let's jump straight into Revit and get ourselves going. So for those of you who have seen the second video in the series, this model is going to look familiar. So we very quickly put together this architectural model. And what we're going to do today is we're going to start a brand new project and we're going to look at it from a services point of view. So for example, we might model a bit of ductwork. Now we don't want that ductwork to be part of the architect's model. We're going to keep the two separate, okay? But we're going to want to be able to federate those models within Revit so we know where we need to place the ducts. So first of all, let's close this project down and we're going to start up a new one for our duct model, let's call it. So either by closing all of the views or go File and Close. That will close the architect's project. And under Models and New, I'm just going to start a new blank project. So this project is going to contain all the ductwork, but we're going to want to be able to see the architect's model. What we can do within Revit is link other Revit models into other Revit models. On the Insert tab, I have the option here to link a Revit model into this project. And we can see here our architectural model from our second Revit live session. Now before I load this into the project, I need to have a look at the options down here for the positioning. So we have some auto options and we have some manual options. The manual options will allow you to manually click somewhere within your project to place the architect's model. The pick point on the architect's model we can choose based on the internal origin point, the base point, or the center extent of the model. And with auto we get a similar set of options. We can line up the center of the architect's model with the center of our model, the internal origin point to internal origin point. And for those of you who don't know what the internal origin point is, it's kind of a hard fixed center point of your project. Center to center is just kind of the center of all the elements that you've added. But the internal origin point is the center of the extent that Revit can go to in any direction. So the size of the Revit project goes on for kilometers into each direction. Okay, there is a hard limit to how far out from this center point you can go, but this center point is slap bang in the middle and is fixed. Okay, so we can line those two up between the two projects. We have the option to line up by shared coordinates. Now the architect's model is set up with its real world position that we're going to go with this series, but our project isn't. Okay, so we can't really use that option just yet, but we will do later on. And you've also got the project base point to project base point, and again we'll see what the project base point is in a moment. So for this one I'm just going to go internal origin to internal origin. Click the open button and that's going to load in the architect's model. Now before we go ahead and start doing anything, we're going to want to correctly locate our project to match that of the one for the architect's model. If I just change the view in the project browser to our site view, what we can see in here is the project base point and the survey point. Now the ones in our project are the blue ones in the center of the screen here. And we can see that in the architect's model, that the project base point and survey base point have been placed on the intersection of grid lines A1. Now if I tab through with the tab key, I should be able to select the survey point. And we can see that the north-south and the east-west coordinates are set to 1000 millimeters. We can also see that the orientation to north is slightly off axis, 10%. Okay. Now if we have a look at our survey point, again if I just tab through, you can see at this particular location it's 0, 0. And the project is perfectly aligned north at the moment. So we're going to want to set up our coordinates to match that of the architect's model. That way, if we start linking their project in the future, or they need to link our project into theirs, we can do it based on coordination. Okay, and it becomes particularly useful when you start working with other applications, which again we'll see in a moment. As the architect's model already has this set up, what I can do is I can go to the Manage tab, I can go to the Coordinations tool, and we can simply acquire the coordination from the architect's model. Now if this happened to be the other way around and we had this set up but the architect didn't, we could push the coordinates using the Publish Coordinates. Also, we can specify the coordinates at a point. We do know that on the intersection point of A1 that it's 1000 by 1000. So if I wanted to specify that, I could click that point and enter those coordinates. But for this example, we're going to use the Acquire tool. With the Acquire tool, all I need to do is click on the linked architect's model and it'll acquire the coordinates. Okay. And we can see that our 0, 0 has now moved. So our survey point, which was originally down here at 0, 0, if I select it, it's still at 0, 0, but the 0, 0 within our project has physically moved. Okay, and the project base point, which appears to have stayed still, has technically moved. We can see that the coordinates have changed there. Now, I'm going to line my project base point up with that of the architect's model. And for this one, I'm just going to simply left click and drag our project base point, and I'm going to snap it to the intersection points of grid line A1. Now I can't do that with the survey point, not just yet, because the survey point is 0, 0, and if I physically move that in this view, it will still be the 0, 0 in the new location, and we'll just be moving our project relative to that of the architect's model, which at the moment is perfectly lined up. So in order to physically move the survey point, we have to unclip it first. You've got this little paperclip icon. If I click on that, if I start moving the survey point around now, we'll see the coordinates physically change. So it's no longer locked to 0, 0. I can place that on the intersection points of A1, and we can see the coordinates have updated, and I can clip that back into place. With this now set up, and just to point out as well that the orientation of our project did change. We can see that it's now at an angle to true north, 10 degrees. If you wanted to manually change that, just to point out the tool, if I go not to coordinate, it's position, you have the option of rotate true north. It works exactly the same as the rotate tool in general, except you'd be rotating the entire project relative to true north. When you do that, you'll need your view to be looking at the true north. At the moment, we're currently looking at project north, which gives us nice vertical and horizontal lines, even though this project is technically a 10% angle, or 10-degree angle. If I just change this to look at the project compared to true north, so north is now at the top, you can see our project is at a slight angle there, which wouldn't be a very easy way of modeling. So we'll change that back to project north. So now that we've got the architect's model linked in and we've positioned our project the same, we're going to want to start setting up our project. First thing we're probably going to want to look at is the levels. And for that, I'm going to jump into the south elevation view. Now here we can see the levels in the architect's model and the levels that are in our project. Now, it's not too clear to see the ones in our project, but we do have a level 1 and a level 0. So I'm going to select one of those levels, and I'm just going to extend that off to the side. And it should make it a bit clearer as to where our levels are and where the architect's levels are. So I'm going to want to set this up so that if the architect makes a change, we get notified the next time we open up this project. So I want to establish a relationship between my levels and the architect's levels. And for that, we're going to use the monitor tool. If I go to the Collaborate tab, we have a button on here for Copy Monitor. And I can select a linked in file. And in this case, I'm going to select the architect's model. We're now inside this Copy Monitor mode. And on the ribbon bar, I have a monitor tool. By selecting my level 1 and then selecting the architect's level 1, we get this little heartbeat icon. This indicates that Revit's now monitoring the relationship between those two levels. Should anything change in the architect's model in regards to the name of the level, the elevation of the level, so on and so forth, we will get notified and we can then make a decision on what to do. I'm going to do the same with level 0. I'm going to monitor our level 0 to the architect's level 0. Now we don't have a level 2, 3 roof or parapet in our project yet. I could manually create those and then monitor them. But conveniently, we have a copy tool as well. If I select the level 2 in the architect's model, Revit's going to make a copy of that in our project, and it's automatically going to establish a monitoring relationship between the two. So I can just simply go up this project, clicking on level 3, roof, parapet, and Revit's going to copy those levels into our project and monitor those. And again, if I just select one of our levels and we'll snap that into alignment with our existing levels, we very quickly created a copy of the levels in the architect's project, and we've established a relationship there, so should anything change, we will know about it. The last thing that we need to do is click the green Finish tick button on the ribbon bar, and that will apply the changes. Now, just before we come out of here, I'll just point out that we also have these coordination settings. Now, I'm not actually going to change anything in here, but when it comes to copying elements from LinkedIn files, you might not necessarily want the exact same component that's being placed. For example, if the architect's placed some sinks and air terminals just to show where the positions are and use some generic models, we might have a library of components already that we want to use that are going to be the actual components in the project. Using the coordination settings, we can set up a mapping. So when it copies an air terminal from the architect's project into our project, we can tell Revit not to copy the exact fixture, but to grab from our library the component that we want to use and place that in the same location, and again establish a relationship. And it's a very quick and easy way to create these components within our project if the architect's models already established where those items need to be located. Okay, so let's click the green Finish tick button and we'll apply those changes to our model. So let's see what happens should we make a change in the architect's model. So I'm just going to give this a quick save and let's call this ducts, because we'll create some ducts in this model in a moment. And then we need to close this. Okay, so I'm just going to go File and Close. And then we're going to open up our architectural model. Looking at the level, so again, I'm going to jump into the south elevation view. Maybe we will change the elevation of the parapet. So I'm going to select the parapet level. Currently at 16,500 millimeters. Maybe we'll make that a nice round 1700 millimeters. Maybe we made a mistake when we were first designing this, or we've decided later that we want to increase the height of the parapet. That's updated, and you can see that the external walls have also increased in height, with the top of the walls being attached to the parapet level or constrained to the parapet level. Again, I'm just going to save the architect's model. That's the only change I'm going to make. I'm going to come out of it and we're going to jump back into our ducts project. And what we should get is a warning telling us that something has changed in the architect's model. You can see here this warning's popped up telling us there's an instance of a link which needs coordination review. I can expand this warning if I want to and get a little bit more information, but I can't choose any settings from here. So I'm just going to make a mental note that I need to review some coordination issues and close that message. Now that we're back inside this project, we can clearly see that the parapet within the architect's model has changed to 17,000 millimeters, but the parapet within our project is still at 16,500. We know that we need to do a coordination review. So I'm going to go to the Collaborate tab to the Coordination Review tool. And just like the Copy Monitor tool, all I need to do is select the linked in model, and it's going to show us any issues that we need to look at. I can see that there's a new and unresolved issue. The category is relating to levels. The issue is regarding position, and I can see the issue here where the level has moved by 500. I can expand that if I want to, and I can identify the components that are involved. Towards the right hand side we have a few options. We can add a comment against this. We don't have to make a decision now. We can postpone this and deal with it at a later date. But under the action column, if I click in the postpone box, we can expand that and we can choose a different option. As well as postponing the decision, I can reject the change. I can accept that there's going to be a difference between the architect's model and my model, in which case it will no longer notify me of this and it'll leave that 500 mil difference. But it will keep monitoring. So if anything else changes in the future, it will tell us again that there's been a new change. And lastly, I can choose to move the level within our project to match that of the architect's model. And that's what we're going to go with here. So we've moved level parapet selected. If I click the OK button, Revit will move the parapet level in our project to match that of the architect's model. Now we've monitored between elements of the same type, levels and levels, but you can establish relationships with pretty much most things. For example, if you're running a pipe against a wall, you could establish a relationship with that pipe and the wall, and then should the wall move for any particular reason, we can get notified and we then know to adjust the pipe so that it still sits running along the face of that wall or inside the wall. So now that we've seen what happens when we make a change between linked models with monitored components, let's have a look at the interference tool. So for this one, we're going to have to do some modeling because at the moment, our project is empty. I'm just going to jump into the level 0 view and we're going to place a duct. Okay. So I'm going to go to the Systems tab and I'm going to start the duct tool. I'm not really bothered by the settings, but I'm just going to change the elevation here just to make sure that we can see it within this view. And then somewhere I'm going to go through a couple of walls. So maybe we'll start in this room here. We'll go through this wall, I'm going to go through this wall, and into this space on the right hand side. So we now have a duct, but we know that it's clashing with these walls. What we can do within Revit is run something called the interference tool. If I just go back to the Collaborate tab, we have this interference check, and it gives us a very basic clash detection within Revit. If I tell Revit to run the interference check, and then we look at the linked architectural model, and we look at our project, I can choose what I want to check against what I want to check. We know in our project that we're going to test this duct, and we know we've created an issue with walls, so I'm going to select walls in the architect model. And Revit is going to have a look and see if there's any issues of walls and ducts clashing. Click the OK button, and we get this interference report. And I can see for ducts, we have two issues. Okay. And if I just move this off to one side, we can select these issues and we can see where they are within the project. It's a very basic, low level, quick and easy way to look for simple issues. Revit works with other applications quite well. And if you've got the AEC collection, you've also got access to Navisworks. And Navisworks, we can run clash detections, but it's a little bit more sophisticated. You can add tolerances and stuff like that. So let's have a look at how Revit works with Navisworks. Now I'm just going to save this ducts model. So we now have a duct that's running through a wall in a linked file. I'm just going to switch to Navisworks. And I'm going to open up the two models. I'm going to open up the architect's model and I'm going to open up our ducts model. So I'm going to go to Open and I'm going to select our ducts model. It should only take a few seconds for this to open. It's not a particularly large model, just a duct essentially. So Navisworks is going to look at the file, it's going to read it, and it's going to bring that into this project. Okay, and we have our duct. Because we've already correctly located the two projects, we've set up the coordinates, I should be able to simply, and I didn't want to click open, if I just click on the little drop down to the side, append. I'm going to append the architectural model. So instead of opening up a new project, this will federate the architectural model with our ducts model. And in a second, we'll have both of them in this project. There we go. So we now have our architectural model. And in there, we have a duct that's clashing through some walls. And you can just about see that there. We're going to run a very basic clash. Okay, so if I just expand this window a little bit, I'm going to add a new test. And I'm just going to simply say that I want to clash our ducts model against the architect's model. Hit the run button and we should get a number of issues appear. And I can see I've got a total of 3. So the first clash, this is just because in the architect's model we've placed rooms and we've not gone into any detail in setting up this clash detection. So this is a bit of a non-issue, so we'll ignore that. Looking at clash 2 and clash 3, we can see this is where the duct goes through the walls. Okay. So what we need to do is be able to identify where these are within our Revit projects. Okay, it's a nice simple model that we've got, but it might be difficult from these to identify where they are, or a bit of work to locate them within Revit. So what I'm going to do is I'm going to place our Navisworks and Revit side by side very quickly. I'll just shrink this window a little bit. Okay, so we can see Navisworks and we can see Revit. And what we can do in Revit is if I go to the Add-ins tab, External Tools, we can enable this Navisworks Switchback feature. Okay, and then what we can do is if I select the duct in Navisworks, right-click on it, I can select Switchback. And what that's going to do is in the open project in Revit, it's going to create a new view with the same orientation of Navisworks with the component we had selected, also selected in Revit. Okay, and if I just make this full screen for a moment. Now you might be thinking to yourselves, this isn't a very convenient view for fixing this issue. Okay, but the key thing is, with that selected, I can create a selection box which is going to nicely crop the 3D view to the extent of the element that we used for the switchback feature. Okay, and we can see the duct there going through those two walls. Now it's actually the architect model that we need to fix this in. So we need to create the openings in the walls for this duct to go through. So I'm going to close this project down and open up the architect's model. We shouldn't need to save anything because the only thing that's changed is the views being cropped. So I'm going to open up the architect's model. I'm going to go back to Navisworks and let's start with Clash 2. We're going to have a look at this wall. I'm going to right click on it. I'm going to select Switchback, and within Revit it's going to take us into the project with the component selected. Again, I'm going to section box the component and we can see the wall in question. Now the one thing we've not done yet is linked the duct model into the architect's model. So I'm going to very quickly go to the Insert tab, link Revit, and select the ducts model. Now I could use internal origin to internal origin because they are technically aligned. I can also now use by shared coordinates because both projects have the same coordinates set up. And if I link that in, we should see the duct going through the wall here. Now we need to modify this wall so that we have an opening around the duct. So with the wall selected, I'm going to edit the profile of the wall. Now, I might want this hole to be slightly bigger than the duct. Okay, so there's a bit of a clearance around it. I'm going to select the circle draw tool and I'm going to add an offset, maybe 50 millimeters, just so we can see what's happening. And if I just zoom in on this duct, I should be able to pick up the midpoint. And if I snap to the face or the edge of this duct, you'll see that the opening that it's going to draw is actually 50 mils offset. That's all I need to do. Click the green finish tick button and Revit will create the opening around the duct there. So that's technically that issue fixed. Now if I save the architectural model and we go back to Navisworks, what we can do is, if I just make it full screen again, is we can refresh the linked models. Okay, and what Navisworks is going to do is it's going to have a look at the duct model, it's going to have a look at the architectural model, and it's going to update any changes that have happened. And once it's done this, it should realize that we need to rerun these clash tools again, this clash rule that we created. And you can see that it's created this warning sign here, telling us that we need to update it. I'm just going to hit the update all button. And if you look at the clashes below, the 3 clashes that we've got, you can see that it's recognized that one of those issues has been resolved. And if we have a look at that now in Navisworks, you can see the opening that we created there. So Revit has a number of collaborative tools, more than what I can go through here today. So that's what we're going to have a look at for now. Do check out our 4th session in our Revit Live series, where we're going to have a look at organizing your Revit project. We're going to take any questions offline, so if you've been watching this and you've sent some questions across, we'll get back to you after this feed. And again, if you've not seen any of the other videos in the Revit Live series, particularly the 2nd video, do go to the Man and Machine YouTube channel. And again, thank you all for watching.